Hello everyone, my name is Nishant Pradhan and my topic is Atomic Absorption Spectroscopy, BSc Maths 3rd semester, and my roll number is 21SS0348. Introduction on Atomic Absorption Spectroscopy. Atomic absorption spectroscopy is a very common technique for detecting metals and metalloids in samples. It is very reliable and simple to use. It can analyze over 62 elements. It also measures the concentration of metals in the sample. The first atomic absorption spectrometer was built by CSIRO scientist Alan Walsh in 1954. Shown in the picture, Alan Walsh left with a spectrometer. Elements that are detectable by atomic absorptions are highlighted in pink in this periodic table, as you can see below. The technique uses basically the principle that free atoms gas generated in an atomizer can absorb radiation at a specific frequency. Atomic absorption spectroscopy quantifies the absorption of ground state atoms into the gaseous atom. The atoms absorb ultraviolet or visible light and make transitions to higher electronic energy levels. The analyte concentration is determined from the amount of absorption. Concentration measurements are usually determined from a working curve after calibrating the instrument with standards of known concentration. Atomic absorption is a very common technique for detecting metals and metalloids in environmental samples. As you can see below is a flowchart on atomic absorption spectrometer, where it consists of hollow cathode lamp, nebulizer, atomizer, monochromator and detector. As you can see is a machine which helps in atomic absorption spectroscopy. Another is a schematic diagram of atomic absorption spectroscopy. Light source. Hollow cathode lamp are the most common radiation source in atomic absorption spectroscopy. It contains a tungsten anode and a hollow cylindrical cathode made up of element to be determined. These are sealed in a glass tube filled with an inert gas, neon or argon. Each element has its own unique lamp which must be used for that analysis. As you can see is a hollow cylinder which consists of quartz window, pyrex body, cathode and anode. Nebulizer. It sucks up liquid samples at controlled rate, create a fine aerosol spray for introduction into flame. Mix the aerosol and flame and oxidation thoroughly for introduction into flame. Atomizer. Elements to be analyzed needs to be in atomic state. Atomization is separation of particles into individual molecules and breaking molecules into atoms. This is done by exposing the analyte to high temperatures in a flame or graphite furnace. Atomizers are of two types: flame atomizers and graphite tube atomizers. Flame atomizer. To create flame, we need to mix an oxidant gas and a fuel gas. In most of the cases, air acetylene flame or nitrous oxide acetylene flame is used. Liquid or dissolved samples are typically used with flame atomizers. As you can see, it is a flame atomizer which consists of light source, a flame, a detector, a atomic cell and a sample. Graphite tube atomizer uses a graphite coated furnace to vaporize the sample. In GFAS samples are deposited in a small graphite coated tube which can then be heated to vaporize and atomize the analyte. The graphite tubes are heated using a high current power supply. Monochromator. This is a very important part in a AA spectrometer. It is used to separate out all of the thousands of lines. A monochromator is used to select the specific wavelength of length which is absorbed by the sample and to exclude other wavelengths. The selection of the specific light allows the determination of the selected element in the presence of others. detector. The light selected by the monochromator is directed onto a detector that is typically a photomultiplier tube whose function is to convert the light signal into an electric signal proportional to light intensity. The processing of electric signal is fulfilled by a signal amplifier. The signal could be displayed for readout or further fed into a data station for printout by the requested format. Applications of atomic absorption spectroscopy are determination of even small amounts of metals, lead, mercury, calcium, magnesium, etc. as follows. Environmental studies, drinking water, ocean water, soil, food industry, pharmaceutical industry.